Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Tenkropki by Calvin Joy, and I think it's also by Sudoku? Um, Hold on, let me take a look. I'm gonna pause just to make sure. Yeah. Okay, so the puzzle is by Calvin Joy, but I think it's basically a collaboration between Sudoku and Calvin Joy. It was posted by Sudoku, which is why I was a little confused by why it says Calvin Joy only. But you know that's cool. They give props to each other, which is cool. Anyways, here are the rules. Normal Sudoku rules apply. That is, each row, column, and 3 by 3 region has to contain the digits from 1 to 9 once each. We also have Kropki dots, where digits joined by a black dot are in a 1 to 2 ratio, and digits joined by a white dot are consecutive. Not all dots are shown. So for example, if this were say a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio. If this were, for example, say a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive with each other. And we also have Tenkropki lines, where every set of 4 adjacent digits on the peach line must contain a digit from each of the X or the 10 pairs, subsets of 1, 9, 2, 8, 3, 7, and 4, 6. So you notice that these sets add up to 10. That's why they're called 10 pairs here. And for every 4 adjacent digits on this line, you must have one digit from each of these subsets. So 1 out of 1, 9, 1 out of 2, 8, 1 out of 3, 7, 1 out of 4, 6. And a 5 may not appear on a Tenkropki line. Okay, that's pretty important. Digits on a line may repeat if allowed by other rules. Okay, so as an example, you could have something along the lines of 1, 8, 6, and 3. And that would satisfy this part of the Tenkropki line because we have one digit from the set 1, 9, one digit from the set 2, 8, one digit from the set 3, 7, and one digit from the set 4, 6. And that occurs all along this Tenkropki line. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so like other, well, okay, first, let's figure out where all the 5s can be. Well, let's figure out what this has to be. We have 3 digits, all separated by 2 black Kropki dots. Well, in my experience, basically in normal Sudoku, it'll always be either 1, 2, 4 or 2, 4, 8, right? Because those are the only sets of 3 digits where you can have one being double of one digit and then the next being double of that digit, right? So either way, 2 and 4 have to be here. So this is either 2 or 4. This is 2 or 4, and this is 1, 2, 4, 8. This is 1, 2, 4, 8. 1, 2, 4, 8 here, and 1, 2, 4, 8. Now 5 cannot be on the Tenkropki line, and 5 cannot be any of these cells. So 5 has to be in one of these 3 cells here, and 5 has to be one of these 3 cells here. Well, this cannot be 2 or 4, right? Because one of these has to be 2 or 4, one of these has to be 2 or 4. If that's the case, this can never be 2 or 4. So if this was 1 in either of these spots, this could not be 2. So this doesn't work. So this can never be 1 then. it could be 1, 2, 4. So the 2, if it's 2 here, that's 8, 4, 2. So it could be 1 here. That's fine. Or it could be 3. If these are 4, it'd be 1, 2, 4, and it could be 3 or 5 here. If it's 2, 4, 8, this could be 7 or 9. So that works for any of them. Okay, that's interesting. Let's just start coloring this long Tenkropki line. We're going to make it, I don't know, green, red, yellow, and blue. So these all have to be, let's make that blue. And this is yellow. These all have to be different sets, right? Because you have every 4 adjacent digits on a peach line has to have one from each of these sets. Well, again, these 4 digits contain a red, a blue, and a yellow. Therefore, what's the last one? It must be green, right? So every 4th set is the same set, right? Because you have 3 that stay the same, and the 4th one is removed from the previous 4 adjacent sets, or previous 4 adjacent digits. So therefore, this must be blue. This must be yellow, right? Therefore, this is green, red, blue, yellow, green, red, blue, yellow, green, red, blue, yellow, yellow, not red, and then green, red, blue. Right, so green, red, blue, yellow, green, red, blue, yellow, green, red, blue, yellow, green, red, blue, yellow, red, blue, yellow, green, red, blue. Okay. That's interesting then, because hmm. Huh. What does that mean? I'm not sure. Um, these are 1, 2, 3, 4, 6, and 8. Right? This must contain one of each set, but this cannot be blue. So one of these must be blue. We also have a green and a red in this. And we have a yellow. So okay, so the remaining cells in box 8. Okay, where is the 5? Well, there we go. Where is the 5? Cannot be here because 5 cannot be double anything, any other digit, and it can't be, if you double 5, you get 10, which is not another digit. Can't be on the Tenkropki lines, so it must be one of these two, which means this cannot be 5. Where is the 5 in box 5? Cannot be any of these cells because of the 5s here. Can't be any of these cells because of the 5s here. Can't be any of these cells because of the 5s here. And can't be on the Tenkropki line, so this has to be a 5. Well, since this is a 5, these can't be 5. These can't be 5, and these two can't be 5. So where's the 5? It has to be here, in box 6. 5 cannot be here. Where is the 5 in row 8? It cannot be any of these cells because they're Tenkropki lines. Can't be here, so it must be one of these two. Has to be one of these 5. And it has to be one of these 3. 5 can be any of these. That's fine. We have 2 greens here. Therefore, the greens cannot be 2, 8 or 4, 6. Excuse me. Well, actually, let's look at it this way. If this is 9, actually, if this is 7 or 9, that means 8 has to be essentially both of these, right? Which would mean this is 8, 4, 2, and this is 8, 4, 2. So where would the 2, 8 set be? It could not be green, red, or blue, so it would have to be yellow. But then this is 8, 4, 2 also, which would mean the yellow couldn't be 2 or 8 either. But then that's a contradiction then, because we don't have a 2, 8 set then out of green, red, blue, or yellow. So this can never be 7 and 9, and this can't be 8. So we have a 2, 4, or 2, 4 going to either a 1 or an 8 here. So the green, again, cannot be the 2, 4 pair, because both of them are shown in column 4, and they are eliminated from ever having a 2 or 4, because we have both of the members of the set here. So the green is 1, 3, 7, or 9, but we're not sure which. Well, one of these must be 1 or 3. Right? Because it's either 1, 9 or it's a 3, 7 set, because it cannot be the 2, 8 set because they're eliminated by the 2, 4 pair here. And this one must be 1 or 3 because it can't be 5 and it can't be a 7 or 9 as we showed, because 8 and 8 would be here. Then this would be 4, 4. This would be 2, 2. And where's the 2, 8 set? It cannot be any of blue, green, blue, red, or yellow, but it also can't be blue, red, or green. So it can't be any of the sets, which is not correct, right? So this cannot be 1 then, because one of these is 1, 3. This is 1, 3. So the rest of the column, excuse me, cannot contain 1 or 3. Therefore, this must be an 8, which forces this to be 4, which makes that a 2. Therefore, the 2, 8 pair has to be yellow, because none of green, red, or blue could be the 2, 8 pair, because they all see this one. Therefore, the yellow is the 2, 8 pair. Well, this can't be 2 because of the 2, 4 pair in this box already, so this must be an 8, which makes this a 1. Therefore, that makes this 3. This has to be 1 to 2 to 4 to 3. This cannot be 3 or 7 pair. This has to be a 1, 9 pair here. So this is 8. This can't be 2, so this must be 8 also. This is 2 or 8. This cannot be 1 because of the 1, but it has to be 1 out of 1 and 9, so this must be 9. We have a 1, 9, 1, 9 pair here. The remaining digits are 5, 6, and 7. These are consecutive, so it must contain a 6 in one of these two cells. Therefore, this is 5 or 7. This is a 2 or 8. So all the yellows are 2 and 8s. All the greens are 1 and 9. We don't know which one's the 4, 6 or which one's the 3, 7. The remaining digits here are 6, 7, and 9. Well, 9 cannot be here because that's part of the green cells. It could be 6 or 7, though, here. Oh, we have a 6, 7, 9 triplet in box 6, which eliminates 6, 7, and 9, the rest of the box. So this can't be 9, this has to be 1. This can't be 1 or 6, so therefore this can't be 3 here, because that would require 6 to be here. The remaining digits here are 2, 3, 4, and 8. Well, 2 and 8 cannot be in the red cell, so this is 3 or 4. Hmm. We have all the greens. One of the greens has to be in this Tenkropki cell. So this can never be 1 or 9 because we already have all the 1s and 9s accounted for. In this box, well, 2 and 8 cannot be in any of these cells. 2, 8 cannot be the red cell. One of 2 or 8 is in this Tenkropki cell, but where's the last one? It has to be here. So this has to be a yellow, and it must be 2 or 8. 2 or 8 can only be next to 1 or 4. 1 or 4 can only be next to 2 or 8. So this is also a 2 or 8. It is a yellow. So this must be 2, which makes this 8. This can't be 2 or 8. So this has to, instead of this being red, this has to be the blue one, right? Because the red and blue are the 3, 4, 6, and 7. We already have the red 3, 4. This must be the blue 3, 4 then. This can't be 5 because of this 5. This is a 6 or 7. We already have 2 blues. This has to be the red 6 or 7 then. Which means this has to be green and therefore 9, which makes this a 1, which makes that a 9. 9 cannot be any of these cells here. Where is the 9 in box 2? It has to be here. So this is a 9. 1 has to be one of these cells. So 1 has to be one of these cells here. The rest are blue. This is, well, actually, we don't know what that is. We have another yellow here. So one of these is a 2. One of these is a 2 or an 8. This cannot be 3. Where is the 3 in... Actually, where is the 4 in row 6? Can it be any of these because that's a 4? Can't be here because that's a 4, so it must be here, which makes this a 4. So the blues are the 4s and 6s. So therefore, this must be 4, this must be 6, this has to be 3. This can't be 6, this can't be 6. This has to be the 6. This has to be 6, which makes this a 7, which makes that 6. So this is blue. This has to be a 3. This is 3 or 7. This is 3 or 7. This is 3 or 7. This can't be 6, so this must be 4. This is a blue then. This is blue. This is blue. So, wait. No, this is not blue. This is blue. These are both yellow. And this is a yellow. So this has to be green. This is an 8. This can't be 7, so this is a 5. This has to be red. We're missing a 2. And we're missing a 6. Well, this can't be 6, so this must be a 6, which makes this the blue. This has to be yellow and a 2. This 6 can be next to 5 or 7. We're not sure which. The remaining digit, this can't be 2, so this must be 8, which makes this a 4, because it has to be in a 1-to-2 ratio with 8. This is 1, 3, and 7. So we got a red and a pink. Or sorry, green. This cannot be 6, so this must be 4. None of these can be blue, because we already have 2 blues here. Therefore, this is the blue out of these 4 cells. So this must be blue, and it must be a 4. Because that's a 6. This can't be yellow. So yellow has to be one of these 2 cells. So one of these two is yellow, which means one of these two is yellow. This is 3 or 7. One of these is green. So one of these must be yellow. One of these also has to be red, so therefore one of these is blue. So we know 2 and 4 are here, because those are the only digits remaining in... this can't be 4, so this must be 2, which means this cannot be the blue. This is the yellow, which means this can't be yellow, so this is blue. That's a 4. This has to be 8 then. The 8 then has to be one of these two, and it cannot be here, so this must be 8. So this cannot be yellow, which means this is yellow, so we have 1, 2, 3, 4. That's also the other yellow, and that must be 2. 4 is here, so this is blue. None of these can be blue. So this could be... That was one of those two. What else do we have? This is blue. So we have green and red as possibilities. This cannot be blue. So this is green, red, or yellow. This can't be yellow, so this is green, red, or blue. This can't be blue. So this is green, red, or yellow. This could be blue. Cannot be yellow. So this is green, red, or blue. Oh, that's interesting. Blue's one of these two. Yellow's one of these two. So the 6 has to be one of these. The yellow could be either. This could be... Oh, it has to be 2. So this is 2 or this is 2, right? 8 sees all of them. Actually, where is the last 8? We have 8 8s, right? Yeah. So the last 8 has to be here. So this is 8, and it's a yellow. Okay. What else do we have? The remaining cells here are 5, 7, 9. Well, this can't be 9. We don't know about these. Remaining digits here are 1, 3, 7, 5, 6. Well, 6 cannot be any of these, and therefore this can't be a 6. So this must be the 6 here, then. So this can't be 6. This is the blue, which means this can't be blue. This is green or red. This can't be 1 or 3. So this is 5 or 7. What are the remaining digits, actually, in... we have a 2. Right, 2 cannot be here, 2 cannot be here. This must be a 2. So this is 2 in yellow, which means none of the other yellows can be in that row. Therefore, this is the last yellow, and is 2. Well, we have a lot of 2s now. We have 8 2s. Where's the last 2? It has to be here. So this is 2, which is yellow. The remaining digits in this column, well, 5 can't be here. 5 can't be here, so this must be 5. This is 5, which means this can't be 5. We have also 7 and 9. So this is 7 or 9, this is 7 or 9, which means the 7 has to be in one of these two cells in box 9. So this can't be 7 here. This then must be 1 or 3, because that's only digits remaining in box 9 out of the 7, 9 pair. We are missing a 6. So one of these is 6. Well, it can't be here, so this must be a 6 here. And this is a blue. So the last one is 1, 3, 7, or 9. We don't know which. Out of these, it has to be 1, 5, 7, 9. And this can't be 5. Out of these cells in row 7, it has to be 3, 5, 7, 9. Okay. We have 1, 3, 5, 7 here. Let's remove the corner cells. Not helpful. One of these must be 7 or 9, and then we have a 5 and a 6 with it. Well, this can't be 9. This can't be 6. This is 1, 3, 7, or 9. Where is the 9? Okay, so not what can these digits be? Let's go with these digits. They are 3, 5, 6, and 7. Okay. Well, that's not too helpful. What about these? We have 1, 3, 5, 7. It cannot be 6, right? 1, 3, 5, 7, and no 5 specifically. This is 1, 3, 7, or 9. If these are both green, then this would be 1 and this would have to be 9. So this cannot be 1 here. If these are both red, this would have to be 7 because it can't be 3. So therefore this would be 3. So this is 1 or 3. We have a 5, 7, 9 triplet now in column 3, which eliminates 5, 7, and 9 in the rest of the column. Therefore, this can't be 5, 7, or 9. It must be a 1. Well, this 1 means this cannot be 1, so this is a 3, which means it's not green. It's red, which makes this red also. This has to be green. This is also a green because this is a 1, so this must make a 9. This has to be 7. That makes this 3. This 3 means this has to be 7. So this 7 means this has to be 9, which makes that a 7. This 9 makes that a 1. This can't be 1, 7, or 9, so this is 3. These can't be 3 or 7. This can't be 7, so this is a 5. This can't be 5 or 7, so this is a 9. This can't be 9 anymore. This can't be 5 because of the 5, 6 pair here in the column. So this is 7, which makes that 5. This 7 means this can't be 7, so this is 3. There's no 3, 5, or 9 here. So this is 7, and this has to be 1. Which means these can't be 1, so this has to be a 3. This 3 and 1 means this has to be a 7, which makes that a 9. This is not red. This is not green. This is not green. This is a red, which forces this to be a green, which makes this 1. That makes that 3. Hold up, that's not good. Hold up, okay. What did I do wrong here? Uh, hmm. Okay, okay, well, let's go back. Let's not do this part yet. We know this is not 9 because that's a 9. So this is 7, which makes that 9. Therefore, this is not red. This is not green. So this has to be 3. This can't be 3 or 9. This can't be 3. This can't be 3, so this is 1, which means this can't be 1. So this has to be a red pair. This has to be 1, because it can't be the 3 or 7 pair here. That makes this a 7. So this can't be 7, this can't be 7, this can't be 7, so this is 5, which means this can't be 5. This is a red. This, therefore, must be... Oh, did I mess up this? Yeah, I think I messed this up. This could be a 1. So this has to be 3. Therefore, this is a 1. This can't be 5. 1 is one of these. 2. This is red. This is green. This is green. 5 can no longer be here. So 5 is one of these two, which means this can't be 5. So this is 7, which makes this 9, which makes that a 5. This is red. So we need, well, this is 9. So neither of these can be 9. This has to be a 3, 9, 3, 9 pair. And again, this can't be 9, so this must be 3. So the problem was I didn't fill this with a 1. I'm not sure why. Anyways, this is 3, this is 7, this has to be 3. This is a red, this can't be red, so this must be a red, which makes that a 7. Makes that 1, this has to be 9. This is a 5, 6 pair here. This is green. None of these can be green. So no 1, no 9, no 1 or 9. This has to be a red. We now have a 3, 7. Oh, well, this has to be 3, which makes this a 7, which makes that a 3. This can't be 7, so this is 9, which makes that a 1. That makes that a 7. These are red. These are green. I guess all the 5s are pink. This is a green. This cannot be 3. This can't be 7, so this is 5, which makes that a 7. So this is pink. This has to be a red. There's no 3 or 7 here. This can't be 7 or 5. This can't be 7 or 5, so this is 6, which makes this a blue. That makes this pink, which makes this blue here. That makes this green. We have 2 greens here. That makes that pink, which makes that green. So this has to be 6. This is a 5. All the pinks are 5. This has to be a 9, and this has to be a 1. Yeah, apologies. I didn't fill in this cell correctly. This also had to have a 1. That's why I was running into a problem here when I was solving this correctly, but was having 1 be there. Because I didn't fill that one in correctly. Apologies for that. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.